In the third part, we'll dive right into the model objects, representing the server and ultimately the front-end code. If you're unfamiliar with entities, JPA, UUID, etc., I suggest going back to the previous modules and refreshing your memory a bit, as we'll build a lot on top of that. One way in which this will be different though is the usage of Lombok, which will make our code far more terse. Still, the code here is mostly mock. The real world, Netflix has a lot of code, but most of it applies to algorithmic scheduling, user management, scaling, etc. All of these aren't applicable here. In this lesson, our focus will be on entities and data transfer objects, also known as DTOs, which are sometimes mixed with data access objects or DAOs. There is overlap between both of these concepts, but what we have is generally DTOs as they transfer data to the client. They don't just abstract the database layer. Writing an entity with Lombok is much easier. There are no getters, setters, constructors, equals, hash codes, etc. Notice we still use JPA just like we used to, so we have the JPA entity annotation and then the Lombok annotations. Everything works as you would expect, including the primary key definition, etc. Notice I chose to go with UUID object as a primary key coupled with auto generation. That's a much simpler trick than the one I picked in previous modules. We already talked about using strings for keys. When we use a UUID object, we get a long string that isn't guessable in the database. That means we can expose that primary key to the end user without worrying that he might use it to scan through details of other users, as the string is pretty long and hard to guess. As we saw, we just need to use the UUID object type. There are several other strategies for generating a UUID in JPA. I chose the simplest one. It might not be the best one, but it is convenient. So why doesn't everyone use this approach? Turns out it's much slower than using numeric auto-increment values on a database column. Databases such as MySQL are heavily optimized for auto-increment fields, and string-based primary keys are just slower to insert. Some developers consider that a non-starter, especially when looking at performance graphs, which is scary. Performance really takes a dive for insert operations, while it remains flat when using long auto-increment fields. Personally, I don't think that's a problem. Even for a video app like this, you wouldn't insert too often, and read operations are still pretty fast. This might become an issue if you have a log or auditing table that might include multiple insert operations per second. At that point, you need to use a long for the primary key and make sure never to expose it externally. The name and description fields correspond to these fields in the database. This is the entire definition, as the accesses are generated automatically. We have three one-to-one media relations. These include the three images for every content item, specifically the hero image, which is the big picture that appears on top of the application. The show logo is displayed on top of the hero image. It's a separate image to support different device aspect ratio and layout. And the icon is the image representing a show within the list. Finally, we have the actual video files, which we store in media objects as well. We have multiple video files representing different quality levels of the video. In real life, we can have even more options such as different aspect ratios, languages, etc. Normally, I would like this to be a map between quality and media, but this is a bit challenging to represent correctly in JPA, so I left this as a simple set. For convenience, we place the DTO creation within the entity object. This code is mostly just the construction, but there's one block where we convert the media object. In the DTO, it makes more sense to hold the media as a map instead of a list or set. So we translate the video to a map. I find the stream syntax a bit obtuse sometimes. This is how it would look with a standard for loop. Essentially, for each element, we replace the content with a map where the key is the quality and the value is the media URL. Once this is done, we create a new DTO object with the automatic constructor and return it. And finally, I also added a small helper method to make the code above a bit simpler, so we won't get a null pointer exception if the media is null. This is the DTO object we just created. Notice it's super simple and mostly consists of the Lombok annotations. The strings just map directly to the entity. There's nothing to say here. For the media, I chose to include the icons themselves. I could have taken the approach of returning URLs for the media, which might have advantages in the future. For now, this is simpler, but possibly not as efficient. Using a URL would have had the advantage of caching the data locally for future refreshes. Using the actual icon means all the data is transferred with one request. This is the map we created for the media items. We already discussed this in the stream part before. It maps between the video quality enum and the string URL. For the sake of completeness, this is the video quality enum. Pretty simple, but matches what we need right now. The media entity is another standard Lombok entity with the standard trimmings. We use the same UUID primary key generation logic. Rest of the stuff is pretty standard. Notice that we store the modified time as an instant instead of date. Instant is a Java 8 datetime API class. It represents a timestamp and is more convenient to use than date. The media data is stored in blob storage in the database. Finally, the URL to the media and the video quality enum are stored as well. That means we can have multiple instances of the same media object for various quality levels. One thing I didn't cover here is the repositories for the entity objects. They're all empty as we don't need any finder methods for this specific demo, so it's all pretty trivial. Thanks for watching. I hope you'll enjoy the rest of the course and find it educational.